A very good evening and a warm welcome to the fourth session of the Professional Development Program organized by BMS School of Architecture, Yelahanka, in association with the Indian Institute of Architects, Karnataka chapter. Today's session is titled 3D Printing of Buildings and Components by Dr. Manu Santaram. Dr. Manu is a professor at Department of Civil Engineering at IIT Madras. He has done his BTech from IIT Madras in 1994, MS and PhD from Trude University in 1996 and 2001 respectively. He has received numerous awards from Indian Concrete Institute. As notable ones are Indian Concrete Institute for Outstanding Concrete Technologies for the year 2018 and many, many more. Dr. Manu has also done many projects funded by notable organizations like EPFL Switzerland, IIT Madras, MHRD, L&T, Unitech, Ultratech, St. Gobain Research Institute, and many, many more. Thank you so much, Dr. Manu Santaram, for accepting our invite. The platform is all yours.
Thank you, Ranjan, and thank you, Dr. Shaila, for giving this opportunity to interact with the people in this workshop. Of course, this is a professional development program, so I'm sure that they're going through a lot more than what I'm just going to talk about in the next hour or so. I'm going to share some experiences about the work that we have done on 3D printing and how it is emerging as a potential technology for customized housing. So without further ado, I'll share my screen. Okay. So now 3D printing is something which has been around for some time. It is from essentially the field of manufacturing, and a lot of medical equipment also is being 3D printed these days. In fact, people are even printing biological tissues. So what exactly is 3D printing and why is it useful in construction? So let's take a look at what 3D printing is. Conventionally, when we think about manufacturing, we take a larger object and basically cut it down. I'm sorry, for some reason the automatic slideshow seems to be okay. Yeah. So when we take a large object, we basically cut it down into a smaller size to really prepare the kind of manufacturing component. You must have all worked in the workshop. Those of you who have done your basic engineering or architecture degree would have worked with some level of carpentry or some type of fitting type workshops in which you take up larger objects and basically cut and shape it to size to make it into the desired manufacturing component. However, that involves a lot of wastage. A lot of material that is not fitting into the object is basically getting wasted. So the idea of 3D printing is minimizing the waste by doing a layer-wise deposition of material. So if you look at this component, for instance, you can actually cut out from this block and make it into this component. Another way of doing this is to actually do a layer-wise deposition of the material to get the object in the correct shape. So that's called 3D printing or additive manufacturing. Now, in construction, additive manufacturing can be of different types. You can have additive, sorry, I don't know why this is shifting on its own. So additive manufacturing in construction or 3D printing in construction can be accomplished in two ways. One is extrusion-based 3D printing. The idea is basically you're extruding the material out of a nozzle. Okay, almost like you're pushing something, like from a die, you're basically pushing something through a nozzle that comes out with a desired shape, and then you are printing layer upon layer to build up your structure. That's called extrusion-based 3D printing. And the other option is binder jetting. So here what you do, you have a bed of powder and you spray the ink on the bed only in those locations where you want the ink to solidify the powder. For instance, you may have a bed of sand and you're spraying some type of a polymer on top of the sand in a certain pattern. So the polymer interacts with the sand and encapsulates the sand and causes it to harden only in specific locations. And this is done over a number of layers so that you can actually build up the entire structure. So that's called additive manufacturing by binder jetting. But for the most part, construction 3D printing seems to follow the approach of extrusion-based printing because that's where the maximum size and scale can be realized. So you see here a typical frame-based printer. So that's the frame, okay? And the gantry, which is on top of it, can move along this frame, right? And you have this vertical component that can move along the gantry. So that means you have an X and Y movement possible. and the nozzle itself can move up or down from the vertical frame. Okay, and this nozzle basically deposits the material which is fed in through a pipe, which carries the material from a pump. Okay, so that extrusion-based printing basically deposits the material in that fashion. Now, why is it useful in construction? We know very well that a lot of time in construction, I'm sorry, I don't know why this is going on its own. So a lot of time in construction is spent in actually, okay, there's some setting I need to change, just 1 minute. Just give me a minute, I'll just change this and come back. Just give me a second. For some reason, the slide is changing automatically.
Sure, sir, no problem.
Okay, let me try again. Hopefully it won't change on its own. Okay, so I was talking about the fact that construction 3D printing can be advantageous in a way that we can save on the cost of formwork. And not just the cost of formwork, you can also save on the time. A substantial amount of time in construction is related to actually setting up the formwork and then disassembling it after the construction is done. So if you can work in a system without any formwork, that means you can save considerable amounts of time in the construction project. And of course, the formwork material itself is expensive, and you may have to actually spend a lot of money in trying to create formwork for shapes that are otherwise not really possible. Right? For instance, if you have a lot of curves in your building, such things with formwork can be quite difficult to execute. In such cases, the geometric flexibility that you get from 3D printing can really be a major selling point, right? And especially most of your architects, you definitely know that flexibility in geometry can be a big boon to realize many of your interesting designs, which otherwise civil engineers don't seem to pay attention to, right? Because constructability is not easy with conventional formwork-based systems, right? So the idea is to use 3D printing to ensure construction of difficult to construct objects from conventional construction, right? Now, there are several manufacturers of 3D printing equipment across the world, and you can see that examples of 3D printing are abounding all over the world. And typical examples that are shown here, some of them are from the US, some are from Europe, in Italy. This is actually a nice robotic arm-based printer. So you have a robot basically which can deposit concrete anywhere it wants. This is the printer that we actually have at IIT Madras. It's a frame-based simple printer, which has been manufactured by this company called Twasta. Now, Twasta is actually a startup which has been set up by some of our students who graduated from here in 2016. They set up their own company. So they went into entrepreneurship and set up their own venture. And they've been working with us in 3D printing ever since. Okay, now, one example of how 3D printing can be done in a factory-based setting is shown here. This is actually from an experience in Shanghai, where they have a construction of a basic shed type structure. It's not really a house, it's more like an industrial shed. But you can see here that the components of the wall are getting printed. Okay, so you can see the wall components getting printed. See, you can see the peripheral. So this is the wall component getting printed by the gantry printer, and you see the peripheral walls and the rib in between just to stiffen it. Okay, these are the ribs that are provided in between the peripheral walls to cause the stiffening. So once the printing is completed, these objects are basically stacked in the factory, okay, where they are cured normally, like what we typically do, spray water on top of concrete to cure it for as long as it takes for the concrete to gain sufficient strength. And then these completed elements are transported to the site and put together, either jointed using reinforcement in the cavities. You can see there are a lot of cavities that have been left behind in the printed shapes, okay? So you can actually reinforce between the cavities, or you can simply, if you don't have a major requirement of reinforcement, you can use mortar to join the components to get your 3D printed structure. So these horizontal elements are going to get jointed by a mortar. Similarly, the vertical components here are getting jointed by a mortar joint. Okay, that again depends on the structural requirements that you have for your structure. So this is a simple way of translating 3D printing into an off-site technology. Off-site implying the printing is done in the factory and the printed components are brought to the site to do the manufacturing. Now, you may ask me a question, why is this different from precast? Okay, now if you see the way of manufacturing here, there is no formwork being used. That's the difference from precast. There's no formwork. So you just directly print the elements, you wait until they get hard, right? And they develop sufficient strength, then you transport them to the site. One thing you must remember, the printing is done when the entire concrete is still fresh. Okay, so one layer is printed on top of the other layer when the bottom layer is still fresh. You don't wait for it to harden. Otherwise, you'll never get a bond between the two layers. So to ensure that there is a consistent bond between layers, you need to continue printing in a continuous fashion. You can't wait for the layer to get hardened. So that means you need to spend sufficient amount of time trying to fix up the right type of your mix. The concrete mix has to be very special in this case. So that is made sure by using appropriate types of additives. Okay. So of course, my focus is not here to get into the material part. I want to explore how 3D printing can actually give some sort of benefit for making mass housing. Now, mass housing, you may think we are referring to primarily multi-storied structures that are rapidly put up. But sometimes we also can refer to mass housing in terms of a multiple number of units spread across a very large area. For instance, for rural housing, where land is not really that big a problem. People want their own house for independent living and so on. People are not really that, kicked about the idea of sharing a building with other tenants like most of us in the urban environments are used to. Secondly, when you do individual houses, you can customize each house separately. When you're doing conventional construction with formwork and with brick and mortar, you are restricted to very specific shapes. Okay, and if you really have to make the maximum out of these units, you have to replicate as many of the units as possible. In 3D printing, you don't really need to do that. Okay, now you can actually mass customize houses even in mass housing. Okay, some examples of housing projects are given here. This is a 3D printed building in Moscow. This is the same building while it was being constructed. You can see that this printer basically is set up on site and it is actually just printing in continuously, and apparently the entire concrete printing for this house was done within a matter of 2 days. Okay. In this case, this is a project executed by Vincent Global. This is a 2-storied house, and here you see multiple housing or dwelling units that were created. The company at least claims that they printed components for 10 houses in a single day. So if you really have very large production facilities and you have the right kind of equipment, you can actually mass produce these elements and then take them all to site, providing you have a good transportation network, and then assemble them at site rather quickly and make very quick housing, especially in case of disaster housing or special housing that comes up right after a disaster. All those can be easily accomplished with proper Pakka houses made with concrete. More examples. This is a house constructed by Icon, and this is actually a castle constructed by Rudenko. Again, this is a very fancy structure, no reinforcement in this. It was just constructed to show the power of 3D printing. You can actually find the video of construction of this castle and several other videos of construction of 3D printed structures on YouTube. Okay. This is a municipal building in Dubai, which was built about a couple of years ago. Okay, completely 3D printed building. These are clusters of houses that have been built in Mexico by the company Icon. So again, that's where when land is not a problem, customized units can be built, and that's where you can really maximize the benefit from 3D printing. Again, of course, you can also go for architectural elements, like if you look at the shape of the concrete that has been printed here, could not have been possible with conventional concrete at all, right? You can see interesting furniture elements, okay? And there's a bus shelter that was printed by Vincent Global also. Some more examples of structures. So these are army barracks built by the US Army Corps of Engineers in North America, where they wanted to actually utilize 3D printing as a technology to print barracks for their soldiers in locations where conventional construction could not be done. So that's another major advantage. If you have good transportation infrastructure, you can actually put the printer along with the material at the back of a truck and ship it to wherever you want to do the construction, and you can, without really having to set up other supply chain for conventional construction projects in such locations. This is an interesting example of a very architecturally pleasing 3D printed structure. You can see the kind of designs. It almost looks like a straw, woven straw type texture, which is obtained by 3D printing of concrete, basically. Again, very special concrete columns, which have been 3D printed. You can try and obtain very unique textures with the help of 3D printing. Now, of course, you can also go for more infrastructure related applications. So here, this is actually a pedestrian bridge that was 3D printed. This is a post-tension girder. Okay, you can see that there are several segments which have been printed separately, right? And these segments have cavities in them that are then post-tensioned with the post-tensioning steel. Right, so now, why is 3D printing something which is interesting from the point of view of housing applications? Of course, you all know very well that India needs a lot of housing. We are expecting close to a 1 billion population in our urban areas by 2050. And our housing needs are going to be around 100 million houses by 2030. That's a large number of houses. So many of you may have heard about government's initiative. They've come up with this Global Housing Technology Challenge, which brings in global players in housing with the latest technologies that can rapidly produce multiple dwelling units. Now, of course, those are technologies that are already commercially available and can be immediately implemented on site. But 3D printing is not something that was identified for this kind of a work. But the government did identify 3D printing as a potential future technology for use in constructing houses. And as a result of that, they are also likely to give some funding to set up an accelerator at IIT Madras to help businesses that can promote 3D printing as an application for housing. So that is something that we are currently working on. So why do we want to print houses when we can use other available techniques? As I said, the main selling point, or ultimate selling point, or USP of 3D printing is individual customization. You cannot do that with precast or other such technologies. The other thing is, you might have seen the previous examples I showed you of 3D printing. The walls are all printed with cavities. So concrete is not completely filled up in the wall, right? So you can make the forms structurally efficient. You're no longer bound by the rules of constructability, right? A typical beam or a column does not have to be that particular rectangular shape, because you're not now obliged to fill up the entire cross section with concrete. You can deposit concrete or put material only in those locations where it is required. So you can do some structural optimization and save on the material costs. Okay, and of course, in terms of sustainability also, using less material is always better. The other thing is, because of the cavities that you have, you can do weatherproofing of your structure. So weatherproofing is very important because you can regulate the sound and heat transmission of such walls and ensure that you have a very good livable environment inside the structure. And again, as I said, portability of the equipment and material is quite useful, because you can now send it across to different locations to execute construction projects when you don't have regular supply chain established with conventional construction. Now, the issue is, are we ready now at this stage for deployment? Answer is, of course, no. We are currently focusing on pilot projects because we still need a lot of things to be done before we can demonstrate the real viability of this application. One aspect that is bothering still is, how do we actually put in reinforcement? So when you go for multi-storied buildings, reinforcement placement is very critical. You need to get good level of resistance to structural loads as well as other dynamic loads, which are wind or earthquake based loads. How can we start designing concrete structures which are 3D printed to accommodate the kind of reinforcement or the amount of reinforcement that is necessary to actually provide such levels of structural capabilities? The other thing is, can we automate the finishing process? Now, you may have seen in the examples that I showed you earlier that the layers can be visible from the outside. Now, while many architects seem to like that, but there are several house owners who may want to actually see a typical flat-looking surface that can be painted on. So, can we automate the finishing process? Answer is yes, of course. You can do that while the printing is actually happening, and many people have attempted putting finishing tools right along with the printer to really get the kind of finish that we want. Printing of roofs, foundations, and other horizontal elements can often be a challenge, because very often printing works very well for vertical elements like walls or columns, right, where you continuously move upwards. If you have to spread a large a large way in the horizontal direction, it is not really advantageous to do 3D printing. For instance, you want to print a slab that is 250 mm thick. There is no point in doing that. You would rather print the periphery and fill up the interior with regular concrete. Okay, so that's basically the challenge. How do we actually design these horizontal components efficiently with 3D printing systems? The major issue, which is a major roadblock as far as application of this technology for construction of houses is concerned, is that anything that you do has to be in compliance with the building code requirements. Now, first of all, this is a material which is completely different. It's not a solid, it's got layers. Of course, layers make it solid ultimately, but still, the layering has some sort of an effect on the overall mechanical performance. How do we test such materials? How do we ensure that the capability of such walls to resist typical loads that you see in a residential or a non-residential structure can be there? So how do we comply with the existing code requirements? The other advantage that may occur along with 3D printing is the fact that because of the cavities that you have inside, you can integrate your piping and other electrical utilities within these cavities. But then can we now automate that also? Many of you may have become familiar already with the use of building information modeling software like Revit. Okay, you can integrate facilities which are utilities into the construction with 3D printing. And that's where the real future is going to be, because that's how we are going to be able to do rapid construction with integration of utilities, right? But then there's a lot of work that is required in that area. Then, as I said, off-the-grid construction, where real construction cannot happen, you can take the machine and the material at the back of a truck and then send it across to different locations. But then again, that is affected a lot by the transportation infrastructure that we have. And also it needs a proper design of the machine as well as the material that can be made perfectly portable. There are also other challenges, of course. Our construction industry anywhere in the world, not just in India, is very averse to technology adaptation. Okay, it takes a long time for any new technology to really make headway into the construction industry, which is highly cost-driven also. Now, if you really compare the costs of the material that is used for 3D printing with the conventional construction, you'll find that 3D printed material costs significantly more than your conventional construction. So cost-driven nature of industry can sometimes be a major roadblock, but then that has to be overcome by making an assessment of the overall cost. So cost is not just the material cost, but how long it takes you to actually put together the structure, right? And how efficient is your structure going to be with lesser amount of material that is used. So there's a lot of issues that you need to overcome to really make 3D printing a viable application. Of course, consumers are not going to be very kicked about using new technologies. So if somebody wants to build their personal house, they'll say, okay, why don't I use a conventional methodology? Why should I go for a new one? Right? That's obviously a very true sentiment that you can expect from any house owner. Okay, and there's a lack of ecosystem for scaling up. One has to be able to train the forthcoming consultants, architects, and practitioners who will take this technology to the next level. And again, as I said, regulatory approvals are very important as far as housing is concerned, and lack of transportation infrastructure can make it very difficult for such technologies to reach the hinterland. Okay. Other major issue is that in India, the industry has not really jumped in as far as 3D printing is concerned. Many of the applications I showed you previously, the pioneering work was actually done by industry there. The academics only supported the industry because industry was really involved in getting 3D printing to the mainstream. In India, that has not really happened, although L&T has ventured into 3D printing and are expected to actually make a lot more contribution to this area. So I'll just share with you some experience that we have had over the last 4 years, which ultimately culminated in actually the construction of the 3D printed house, about which I'll talk a little bit more. Okay. So we started off with a very simple frame-based printer. You can see the simple printer, which is hardly about 40 centimeters by 40 centimeters by 50 centimeters in size. So almost like a small table, basically. And it is basically operating on a frame. So this is the frame. And this movable head basically can move in one direction along the frame. The frame itself can move in this direction. And you can see the nozzle, one of the early designs of the nozzle, which was used to print simple materials like lime mortar. This here is lime mortar. This is basically clay. Okay, clay was used to print also. Later, we started printing concrete after we were able to design concrete well enough. Of course, I'm not going to get into the specifics of the materials because it's going to be a little too much for this lecture. But as far as the material is concerned, please remember, I told you that we need to print while the concrete is still fresh. We don't wait for the layer to get hardened. As a result of which, when I print this layer on top of this layer, the weight of this layer and the subsequent layers can press on the bottom layer. When the weight presses on the bottom layer, if the concrete is not properly designed, it will start flowing outwards and it will start getting compressed. And that's not what we want. We want the layers to maintain their shape and size. And that's exactly what you see here in the 3-layer wall and the 4-layer wall, that the shape is perfectly maintained. You don't have any excess compression of the layers that causes the material to be uniform and good for the application of 3D printing. Some more elements that are being printed here. There's a cylindrical element, that's a square element that is printed in 3D printing. Okay. These were just some early trials that we did. The next stage was to start evaluating the material characteristics. Now, typically you may have seen in construction projects, if somebody wants to evaluate the concrete that has been supplied, you'll be making cubes with that concrete and testing the cubes for their compressive strength. If you have a brick, you'll be judging the compressive strength of the brick as well as the water absorption. Now, what kind of test do you need to do for 3D printed concrete? It's not that easy to understand because you can't make a typical cube or a cylinder with this kind of a material, right? You can possibly make an element like a wallet, right? 4 layers are there and these 4 layers are compressed together. And this is the kind of failure that you get in the compression, okay? Now, but how do you determine the size of the layers? How many layers should be there, right? And what should be the height of the layer? What should be the thickness of the layer? All that can be highly variable, because of which we still don't know what would be the right scheme of characterization of the properties of 3D printable concrete. We also did some additional investigations where we tried to understand whether this concrete behaves the same when it is loaded in one direction as opposed to the other direction, and so on and so forth. So there's a lot of material that we worked on in terms of deciding the best configuration for printing and the best means of actually extracting the sample to do the assessment of mechanical properties. Because again, unless you understand what is the load carrying ability of the concrete, how will you use this to design a wall or a column? You have to understand that, right? So that we can get the true capacity of the concrete itself. And that capacity has to take into account the effects of the layers. Otherwise, it's not really going to be showing the true strength of the concrete. Again, some more tests that are being shown here. We also did bending tests for the 2 layers that are printed together, and several other tests also. I'm not going to talk about this in detail here. Of course, these are just some additional elements that were printed just for the sake of printing. Then from this smaller scale printer, we started moving on to a larger laboratory level R&D printer. So in this case, we wanted to start printing elements that were wider and longer in size and could also be printed up to about 50 centimeters in height. Okay, so the idea was to print modules for a simple room type structure. So you see here, this is a test bed, and that's the printer, which is the frame of the printer. So the material is fed into this primer, which pushes the concrete into the pump. While the pump has a retracting movement, it basically takes in all the concrete. Then in one forward movement of the piston, it pumps out all the concrete from the pump, which is carried through this nozzle, through this pipe, and delivered to the nozzle. Okay, so in one forward movement of the piston, we push out about 60 kilograms of the material. Okay, and with that 60 kilograms of the material, we were able to make a module like this, a 3D printed module like this was made, which has a cavity inside. It's got peripheral walls and a corner cavity also, where a reinforcement could possibly be put at the later stage. Okay, now this is again showing a close-up of the pump that was used. The material getting pushed out of the pump is coming out quite uniformly, right? And this is a simple structure that was printed, a square element that was printed using this kind of an arrangement. Now, with this nozzle and with this printer, these modules were actually printed. Okay, you can see these are the modules that are getting printed. The height of the print for each of these modules was approximately 30 centimeters. Okay, the idea was to assemble multiple modules on top of each other to create a room type structure. And that's what we did. we assembled these modules together. You can see this one half module, and that's the other half module, right? And several of these two half modules were actually kept one on top of the other and jointed using mortar, right? You can see the joint here, jointed using mortar to build up this entire structure. This is a simple structure which was then inaugurated by the Ministry of Housing and Urban Affairs, with whom we also conducted a workshop a little later. Okay. We did a national workshop on 3D printing and construction in November 2018. And beyond this, we started venturing into doing other sorts of construction of elements also. So you see here, furniture elements getting 3D printed. So many of you architects will really be interested in what you can do with the building facades, for instance. You can really have the ability to print very interesting facades. We have not explored that in great detail, but yes, that's something that we can do a lot of work with. We can also print overhangs. You don't have to print right on top of the previous layer. You can offset the placement of the next layer in such a way that there's an overhang and can create very interesting intricacies like this, for instance, okay, which you cannot do typically if you are printing layer upon layer. And of course, with facades and with the Jali type printing, you can also get very interesting shapes printed out of these 3D printed materials. Now, you may be wondering why all of them are looking to have the same sort of thickness of the filament. That is dependent on the nozzle that you have. You can control the shape and size of the filament by the size of the nozzle itself. Okay, of course, many of you are also familiar with the muruk that we typically make at home, right? A muruk is basically the same technology. You make the dough, you put it in the die and simply press it and squeeze it out of the extruder. And the extruder gives the shape to the muruk. Okay, so that's exactly the same technology with 3D printing, okay, to put it in simple terms. So this is the larger scale printer, which was then constructed by the same company, Twasta. You can see their name here, logo and the name, Twasta. So they made a printer that could print up to about 1.5 meters. It could still not print an entire floor in the building, but it could print the floor in two halves. So that was the idea behind actually printing a toilet module. So this printer was used, more details of the same printer. This printer was used to print this kind of a toilet, okay? And this was a project that was partially funded by Larsen & Toubro, L&T. And the mandate from L&T was that we should print everything, including the horizontal components like the base slab. So this base slab also was printed completely. You can see the printed concrete here, printing the base slab. And then the walls were printed in two halves, lower half and upper half with the roof. The lower half was printed along with the base slab. You can see this is the lower half, the base slab at the bottom. And you can see the kind of wall that is there. There's only two perimeter walls and the inside is completely empty. Now, to ensure that these perimeter walls could support their own weight and not start collapsing outwards, we placed these steel meshes to ensure that they were integrally linked to each other. And then we could build an entire structure like this. Okay. So this is the wall that is coming up, right? And we also left some plumbing pipes to ensure that we could replace these with larger plumbing whenever desired. So this is the lower half that is completed, okay? And similarly, we printed the upper half in several layers, and the roof also was printed. The roof was printed by giving, of course, the formwork support from underneath. Okay, you can see the formwork underneath inside the roof, and it was supported on top, and then the roof was printed right on top. So this is the upper half that is printed. Now, for the next stage, for the construction of the house, they took this to the new level and set up this entire printer in a factory-like setting where the printer was then put on rails. You can see these rails here. The rails enable the printer to move along one direction as long as you can possibly want. Okay, so the entire printer can be moved so that it prints first on this bed, moves a little, and then starts printing on this bed and moves a little more and prints on this bed. The advantage there is that in the continuous operation, you can continue to print multiple elements. You don't have to wait for the element that is printed on this bed to harden and to be able to take it out. Okay, so you can print continuously on several beds and give an infinite access along one direction. So that's what was done in this case. You can see multiple elements being printed. There's two elements on one bed, two more elements on the next bed, and one more element on the third bed, and so on. So several elements continuously are getting printed and then stacked nearby and cured by spraying water or putting a curing compound until they get sufficiently hard. And then they are brought to the site and assembled by jointing them. So this is one layer, this is the second layer, and that's the third layer. Okay. So this is a curved wall. You can see there's a curvature in this wall. Typically with formwork, it's quite difficult to do, but here there was no real need to worry because we could print the components exactly in that shape, right? You can see the layers. The lintel is basically a precast concrete lintel. Okay, it's a simple precast concrete lintel which is used, right? And of course, we printed. We did not print the roof and the foundations; those were with conventional construction. Okay, with formwork support from inside. So you can see the inside is completed, and we can provide formwork support. These stubs are obviously put for plastering the top surface because people should see a typical building. So we plastered the top surface, and we kept some components which are unplastered just to show the kind of texture that you can expect in the wall. So this is the finished building. You can see this is a patch where we left it unplastered to show the wall texture. Similarly, when you go to the inside of this building, you can see a video of construction of this building on YouTube. Okay, if you do a search for India's first 3D printed house, you can get the video on YouTube, and it will show you the inside also. There are several locations where plastering is not done to show the kind of texture that you can expect from 3D printing. So this is the house that we have constructed on campus in IIT Madras. Twasta is the main company that is involved behind the construction, and they are currently executing a project of a school outside of Chennai, where they have a very vast area of land where they are actually constructing a ground+1 structure for a school. Okay, so again, there are obviously challenges that they will have to meet with to really get that construction project going, because when you're going for ground+1, obviously there's a lot more you need to show with respect to structural design. This is a simple single-story house, only 500 square foot, so structural design is not all that critical. But in that kind of for a school, obviously you need to have very strict quality checks and construction structural checks that need to be done to ensure that you have the safety of the students in your mind. So just to summarize the journey of Twasta and IIT Madras, in 4 years, basically we have done work that is almost equal to about 50% of major 3D printing research groups across the world. We have also executed all our projects. The entire research funding that we have actually used for this set of projects is about 1/5 of what typical groups outside the world, outside and other countries in the world have been using. But the main issue is whether we can scale it up further. That depends a lot on what kind of support we get from the industry to really take this forward. So now, what is the strategy to take this forward? I showed you some benefits that can be obtained from off-site printing. That means you print in a factory and then take it to site and assemble it. But the idea there is the best execution of this could be possible if we can work in the form of, let's say, what to say, you typically see these books from which you can actually select specific designs, right? The client can actually make a choice of the layout and architectural sensibilities that need to go into the construction. The 3D model that is constructed based on the vision of the client's needs by the architect should then be broken down into standardized modules. Now, when you standardize the modules for, let's say you have a straight wall or a curved wall and things like that, when you standardize these modules, you can produce them in the factory in massive numbers and supply these to the sites quite quickly. Okay, so that's where the strategy should be there. If you are doing off-site printing, that means you are printing in a factory and taking to site. Your objective should be to standardize the modules as much as possible. So that's where the need of a 3D construction toolbox is required. So architects especially should take note that they can now produce very standard designs and standard modules that can then be assembled in different ways and forms. All of you have played with Lego blocks. As kids, you would have played with Lego blocks. The idea is the same. You produce your 3D printed elements in the shape of these Lego blocks that basically fit into each other. Okay, fitting obviously is a little bit more difficult on site because you need to join them with mortar and join them with reinforcement and so on. But this can be done. You can standardize these modules and that will make construction a lot more easier. And manufacturing scale production can be done to really achieve the scale that you really want. Okay. For instance, like the Chinese company that claimed that they printed the components for 10 houses in a single day, that is really achievable or realizable. Okay, the entire structure that I showed you for the house, 500 square foot house, the entire structure came up in a time period of 21 days. Now, this 21 days happened in spite of all the research and development that we actually were doing alongside the construction. Okay, if you really have everything worked out well in advance, you can break this time period into probably just a week. So imagine if a person is ready to get the house within a week, that will really make a major difference. Typical houses, we take a few months to construct, 3 to 6 months at the minimum to construct typical houses. If you can cut that down to a week, once the supply chain is established, then that can really be a massive groundbreaker as far as your construction methodologies are concerned. So from industry R&D, to scale up the R&D with support from the industrial alumni, we can actually start building up several structures in a very quick fashion. For instance, those toilet modules that we showed you can be built up in a time period of just 6 to 10 hours. So we're talking about less than a day for the entire structure to be set up. Of course, it will take time for it to gain strength and get hardened and all that. But the time of construction itself is going to be very small. Single-story houses can be constructed in less than 5 days. If you have the components ready, and you can print the components quite rather quickly, when assemble them on the site, and by the time you're done with the finishing, the concrete would have gained sufficient strength and you will be ready for your occupation of the house. Multi-storied G+3 can be also constructed in a very quick time period. Only problem there obviously is the extensive regulatory approvals that we need to achieve before we can really start utilizing this technology. Okay, so what I expect is, given the current pace, the mass application readiness should be achieved in another 2 years. But of course, that needs a lot of financial backing. We are hoping that a lot of industrial support will come with some time, and we'll be able to push this to the next level by appropriately scaling up. So again, the first 3D printed house that we did was a culmination of 3 to 4 years of research efforts. And one interesting thing here is that entire technology is Indian. The company involved in the construction was Indian. They made their own 3D printer. They didn't purchase a 3D printer from anywhere. So it was a completely Indian-made technology. And as I said, without looking to the future obviously means that you need to look at ways of scaling up things and standardizing the production process to really meet up with the demands of the mass housing that the country will have over the next few years. Right. So thank you all very much. I know I packed in a lot of information, but I'm very happy to interact and answer any questions that you may have. Okay, so feel free. Any questions, I'd be happy to interact.
Yes, sir. We do have quite a few questions. First question by Lakshmi Prasad.
Can we make mud walls? Okay, yeah. So as I showed you one of the early trials that we actually did was with clay. Of course, that was at a very small scale. The difficulty with clay, soil, and mud is that standardizing the mixed proportion to really get it to a printable scale, that is difficult. With concrete, we know how these chemicals work with cement and so on and so forth. But yes, to answer your question, yes, we can print with mud. In fact, you can take a look at the internet for a project that they are doing in Europe, where in Italy, I think, where they are actually constructing very large dome-shaped structures, which are 3D printed with soil that is taken from the same area.
What do you mean what?
So next is by Shirupa Dev. Ma'am, you can unmute yourself and speak.
Okay. Good evening, sir.
Good evening.
Yeah, I just have one question, that in case, because you are doing mostly residential, in case there is any service outlet that anyone decides later, after the construction is done, then to do that cutout, is it possible? And will it affect the strength of the structure?
Yeah, so again, just like any regular structure, the strength of the wall obviously is a integral output of the strength of all the layers jointed together. So again, making a cut and removing material, that's not really a big deal. It can be done. It can be done because there's a lot of redundancy built into the strength. Obviously, the strength of the wall required to take up the loads is not as much as what is provided with respect to concrete, because this is very special concrete. It will gain significant bit of strength.
Okay.
So it should be able to match the requirement of any cut that needs to be made out in the structure.
Okay. Thank you, sir.
So I think that also applies to the next question. How about post-occupancy repairs in such structures? The same thing. So repairs can be made. It's concrete, so it takes a little bit more energy to break it as opposed to brick. But yes, if you have the right equipment, you can cut and you can repair in such structures also. But of course, we have not got to that state yet. I mean, the building is hardly about a year old now. We constructed exactly last October. So yeah, so we've not had any need of repair yet, and hopefully we won't have it for the next 10 years.
Next,
yeah.
Shivalinge Gowda, can you please ask your question?
Yeah, good evening, sir.
Good evening.
And it was a wonderful presentation.
Thank you.
So I just wants to know about your project, which you have shown that toilet roofing.
Yeah.
Yeah, the design process is as conventional, and the reinforcement and design and all. And
Here
what was the design mix adopted for that? And what is the limitation for the aggregate size?
Okay, good questions. First of all, as far as the toilet roof slab is concerned, it was printed in 2 layers. Okay, there were 2 layers. Maybe I can show you the picture here again. So just to show you the toilet roof slab. So you can see, sorry, not 2, 3 layers rather. And a single layer reinforcement was kept in the center. Is it 3 layers or 4 layers? Okay.
The first layer is like
there are
cover.
4 layers. The first layer is where the reinforcement is. You can see actually the reinforcement bars jutting out here. So it was basically a mesh type reinforcement that was put on the top, because the size is not large. It's only about this entire size is about 1.2 by 1.2 meters. That's it.
Okay.
The size of the roof element, and it's only 4 layers thick. The layers are about 15 to 18 millimeters in thickness, so it's not really thick. It's only about maximum of 70 millimeters thickness for the roof slab.
Okay, what was the total slab thickness?
No,
75?
this roof slab is about 70 mm. That's it.
Okay, okay.
Yeah.
So this could not be used for the entire house.
No, this is a toilet which is printed separately.
Yeah.
This is not for the house. This is not for the house. The house roof is different. The house roof is okay. It's basically a typical terrace RC slab that was actually cast in situ. That was not printed.
Yeah, yeah. Oh.
So once the walls were made, like what I show in the previous picture here, once the walls were made, the interior, I mean, we put the supports of the interior and we put the formwork for the roof, and the roof was done in a conventional fashion. Conventional.
Yeah. Fine. Thank you.
Yeah. And as far as the concrete mix design is concerned, of course, there's a lot of printed material here. I didn't put that in this thing here. It was aggregate size was limited in this case to only 2 millimeters. Okay. Now that of course depends on the kind of mix and the type of printer that you have. So in this case, aggregate size was just 2 millimeters. So it's actually a mortar. Okay. And the cementitious content included cement and fly ash. And the quantity of cementitious material was very high, about 800 kilogram per cubic meter, which is much higher than your conventional concrete. Okay. Again, there's a lot of information there in the research papers that we've published, and you'll get a lot more information from several articles that are there on this subject.
Next, we have a question from Rakesh.
Sir, very good evening.
Good evening.
Sir, my simple question is, what could be the cost difference for a conventional method of construction to a 3D printing construction?
Okay, now, as I told you earlier, the cost of this particular 3D printed structure, this house, was significantly higher because it was an R&D based house. Basically, we are still doing R&D, trying to fix up what type of materials to use, how best to optimize the material, and so on and so forth, right? And as I told you, aggregate size is restricted to 2 millimeters and cementitious content is very high. So all that leads to a very high cost of concrete. Added to that, we have special additives which make those properties possible. Layer upon layer printing, and the concrete still able to keep its shape. All that happens because of the special characteristics and the use of specialized additives, which are quite expensive. Okay. Now the issue is, can we take it to a level which is similar to ordinary concrete? And that's where most of the efforts around the world are. Can we now involve mixed design strategies that make the structure a lot cheaper in terms of the material? Now, material itself is more expensive, but how much material is required to construct the wall also needs to be seen. That's where you can optimize. Okay. With all that optimization, with all the R&D that we did in this house, the material cost and the overall cost of the building, including finishes and everything, came to about 2,500 rupees per square foot. You know that conventional construction can be accomplished in 1,000 to 1,500 per square foot. Now, once the R&D part is over, once we scale it up, achieving that kind of a cost would not be that big a problem. So you cannot compare cost with just one unit and a single structure that has been built. So you have to accommodate that over multiple structures, because you're printing using a printer. To offset the cost of the printer, it will take you multiple units to do that. You can't really make a printer print only one building. It's not going to be useful. Okay. But if you're using the same printer to build 20, 30 units, obviously you're going to be recovering a lot of the cost of renting that printer. So the cost has to take in several other aspects. Material cost is definitely going to be higher than conventional concrete. There's no doubt about that.
Thank you, sir.
Yeah.
Next, we have a question from Prithvi. Prithvi, could you unmute yourself and ask the question?
I think his question is printed here, which is, what is the least thickness of the wall that can be achieved? Now, there is no simple way to answer this, because your thickness of the wall will depend on the amount of load it needs to carry. Okay. And if it has to carry a large load, obviously you'll have to increase the thickness. That is one thing. Second is, when you are printing a very thin wall, one on top of the other, it becomes extremely slender. And you know that for slender walls, there will be some out of plane deformation like buckling that may happen. For it to maintain its structure while it is getting printed, you need to have a substantial bracing. And that's what you saw in the previous examples that I showed you. There were perimeter walls which were thin, but there was a rib in the center which was running all the way to provide stiffness against lateral deformation. Okay. So with this, the least thickness that we have worked with has been around 80 millimeters. But then 80 millimeters was for the toilet structure that we made. Okay. For realistic walls for houses, you'll have to go at least for 120 millimeters. Okay. In 120 millimeters, not all of it is concrete. You have nearly 40 millimeters of the 120 will be cavities. The remaining 80 only is concrete. So 80 mm is still the amount of concrete that is used, but the rest of it is basically cavities.
Next, we have a question from Suchitra.
Hello, sir.
Hello.
So it was a very interesting topic and very informative, sir, first thing. And my question would be, what would be the lifespan of this 3D printed structure, especially for structure of G+3?
Okay. Now, in typical concrete structures, the lifespan is governed by how long it takes for the steel to corrode, right? And typical brick masonry structures, obviously, the lifespan is governed a lot by the extent of problems that you expect from seepage and other issues. Of course, those are repairable problems, but corrosion of reinforcement in regular concrete is something which is difficult to repair and overcome. So if you look at it in terms of material, you're basically dealing with the same material, right? You're dealing with concrete. If you put in reinforcement in the structure, you'll be grouting the reinforcement. And this concrete, which is sitting outside, which is 3D printed, is still a protective barrier, which will not cause the reinforcement to corrode in its life cycle. So lifespan will be primarily a function of the material characteristics that you use and the kind of structural components that you actually build with. It cannot be any different as compared to a regular reinforced concrete building. It's
Okay.
not going to be any different.
So in future, it is possible to go for higher floors, more than G+3?
Yeah,
That practically would be
it definitely would be possible, but one has to work around the issue of how well reinforcement can be provided. As I told you, it's a big challenge because for a single story structure, it's not a problem at all.
Yeah.
But for multiple stories, you need to provide the right connections so that load transfer can happen between the floors and overall in the vertical direction to take the lateral loading of wind and earthquake. There should be sufficient rigidity built into the walls, and that needs a lot of reinforcement. And that is something which still people are grappling with. How can reinforcement be properly integrated? So right now, there is no clear answer as to when such structures will be realizable.
Okay. Sir, I have another question. At what stage will we do the electrical and the plumbing?
Hi, Suchitra. We do have time constraints, so we'll restrict to one question per participant.
But I think that's an important question. So let me just quickly answer that. With respect to planning utilities, with the current type of lean construction approaches, you can actually plan it while the 3D printing is being done. So that's a major research strategy that we are trying to look at IIT Madras, where we want to see how well we can integrate utilities with the actual construction project itself. So again, the advantage would be to do it as quickly as possible.
Okay, thank you, sir.
Next, we have a question from Pooja M. Pooja M, can you unmute yourself and ask the question?
I guess the question is about, can the 3D printing be applied for restoration and repair of existing structures? It depends on what you would need from it, right? I mean, restoration and repair, you'll typically use material for strengthening existing structures. 3D printing may be useful, for instance, if you have to create some sort of a design that is not achievable by conventional construction. But otherwise, I would not really look at it for a material for repair. It's more of a new construction type of approach. Rework already we've answered that.
We have a question from an anonymous attendee. Are all the walls load bearing, or can column beams be column beam structures be made?
Yes, column beam structures can be made. Again, one has to be very careful about how beams are designed, because beams are horizontal elements. Can we print a column and then turn it on side and make it into a beam? In that case, how do we connect the beam and the column? What kind of joints do we provide? So there are several things that need to be worked out. But yes, walls don't always have to be load bearing. We can make non-load bearing walls and have frame structures. But with 3D printing, it's much more beneficial to actually make the wall load bearing and construct the wall along with the column, so that you don't have to really spend time in making the frame first and then filling up the interior with the wall. With 3D printing, it's much easier to do the entire thing together.
Yeah. Next question, we have Namrata. If you wish to speak to the speaker, you can unmute yourself and ask the question. Namrata.
Hello, sir. So I just want to know how does the foundation work for these 3D printed buildings?
Okay, in this case, the house construction that we did, we basically made a simple strip footing under the wall. But that the foundation obviously will depend on the type of structure you're making. And I was telling about this earlier that there's no point in trying to print the foundation, because it requires a lot of reinforcement and a lot of concrete, and it has to fill up a certain trench in the ground. There's no point in doing that. I mean, you want to create free-form structures with 3D printing. A foundation has a shape and a size, and that needs to be filled in with solid concrete. So we used a simple strip footing in this case.
Okay, thank you.
Yeah.
We have another question from Anand. Anand, if you would like to unmute yourself and ask the question yourself.
Hello. You mean Anand Swami, right?
Yes, Anand Swami.
Yeah. Sir, thank you so much. You have actually opened kind of a great opportunities. What I understand is that we are using a single homogeneous material in 3D printing.
Sorry, we are?
Homogeneous material.
Yeah.
So to my mind, even the form needs to be homogeneous. And we, trying to attempt to compete or satisfy the limitations or try to overcome the limitations by the conventional systems would actually reduce the possibilities what we can have with 3D printing. In the sense, like trying to put a flat roof instead of that, if you have a domical roof or a corbelled structure, it would be much easier, like a kind of a pyramidal roof, or maybe even a vaulted structure can be much effective, because we can avoid the reinforcement, bringing in reinforcement into the structure.
Exactly.
Maybe we can think of a jacquard system.
You're right. I mean, if you look at that example I showed you, that concrete castle.
Yeah.
That's what it does.
Concrete castle is really an interesting revealing form or a structure.
Correct.
So I think when we are getting that kind of possibilities with a 3D printing structure, we should more effectively and forcefully project that aspect of 3D printing than competing in terms of cost, because it is like conventional structure is there. So if we say if we say a modular system or unitized system, if we try to make with a 3D printing, there are other options always available. If we are making a modular system, we have precast systems that are available for that.
Yes.
But precast system can't really do a free form structure.
Exactly.
And that is where this have to be opted for. And
I think
if you can project that part, I think it will help.
I think you've hit the nail on the head. That's where we need you guys. I mean, most of you are architects, and we need your help. Because as civil engineers, we are living in a world where everybody wants everything to be rectangular. We tell them that 3D printing does not make sense when you want to make those rectangular blocks.
Absolutely.
Yeah, you're right. Dome type structures are realistically possible here. We can make a lot of interesting shapes and optimize the material usage also.
And even irregular domes, not necessarily a typical dome what we have historically we have experienced.
No, we are actively looking into structural engineering of 3D printed structures to minimize reinforcement. Because again, if we are set with regular forms and shapes, then we will obviously have a stumbling block wherever reinforcement needs to be used. So we have to overcome that sort of a limitation in the design and go into looking at such interesting structures. Absolutely, you're right.
Sir, I would like to really participate in any of such effort that you are making.
Definitely. If you can contact me, I gave my email address there. Just contact me. I'll also put you in touch with this group called Twasta, so they'll also be happy to get more support.
Sir, could you please type in your email address for all the participants if at all somebody has missed out? You can type it in the chat box.
Yeah.
Thank you. Thank you, sir. I think that's the end of our Q&A session.
Before Ranjan, you wind up the session, I would like to thank sir. Thank you very much, sir, for accepting our invitation. And within a short span, you said yes, you are there for this session, and I really thank you. And I would also like to know, do you conduct any kind of a certification program in your lab so that our students can be a part of IIT Madras when you conduct these kind of
we conduct short courses. We conduct short courses and workshops. Definitely, if your students are interested, I will definitely send across the mailers to you also.
Sure, sir. Sure.
Students can sign up. Sure.
Thank you so much, sir.
Thank you. Thank you very much.
Thank you, sir. The session was indeed very engaging and very captivating. There's a whole lot of questions also being asked. That's definitely because our listeners are very eager to learn about this new technology. And I truly have to agree with you that our industry does take a long time to change and adapt to new technology. I remember our mobile phones during the late 90s were about 1 centimeter thick, and within a decade they've shrunk to a few millimeters. Our brick has been the way it is for the last 5 decades or so, and I think things have to change at the moment. Thank you so much, sir, for your valuable time and sharing your experience and knowledge on 3D printing of building. Thank you once again. Have a great evening.
Thank you. Thanks for the opportunity. Bye.
Bye-bye, sir.